In today's video, we are going to look at parent functions and their transformation. So let's first go ahead and start and talk about what a parent function actually is. Parent function is the most basic function in a family of functions. So basically, when we say the most basic function, we're talking about a function that has no transformations. All right, first we're going to go ahead and look through all of the different rules before we get started. So we're going to see what kind of transformations are possible on these parent functions. So we're going to start with our parent function, our most basic function, y equals f of x. Now f of x could be anything. It could be y equals x, it could be y equals x squared, y equals x cubed. This is just f of x being any family function that you want without any transformations. Now if we go ahead and multiply a number in front of that equation, so we're going to call that a, this is going to cause our function to be vertically stretched. So let's go ahead and just use a parabola as our example. Let's say that this is our standard parabola, and I'm going to take it and I'm going to stretch it, which means I'm going to pull it vertically. When I pull it vertically, it's going to cause my graph to get skinnier. It's stretching up. Now, if I multiply that function by 1 over a, so a fraction that's smaller than 1, this is going to cause our function to be compressed vertically. So again, let's pretend like we have our quadratic, our parabola. That's our parent function with no transformations. If I compress it, which means I'm pushing, so if I'm stretching, I'm pulling it. If I'm compressing it, I'm pushing it down. When I push it down and I shrink it vertically, it's causing my graph to get wider. When we are vertically stretching and compressing, and that number is on the outside of the function, that means that you are multiplying each output. Again, it's on the outside of the function, so you're taking whatever you would have gotten, and then you take that answer and multiply it by your multiplier, whether it's a number bigger than 1 or a fraction that's between 0 and 1. Now let's talk about what if that multiplier is inside of the function. If it's inside of the function, then it's going to be horizontally compressed. This is where things are going to get a little bit tricky. Here's our parent function. If my number is greater than 1, so if I'm multiplying it by a whole number, 2, 3, 4, 5, and it's inside the function, rather than vertically stretching the way it did if it was a whole number on the outside, I'm going to horizontally compress it. So vertically goes up and down, horizontally going left and right. So if I'm going to compress it, I'm going to push it in, and that's actually going to cause my parabola to get skinnier because I'm horizontally compressing. Remember, stretching is pulling, compressing is pushing. So horizontally compressing it is going to have a similar effect as vertically stretching. Now if the number, the multiplier inside the function, is that fraction between 0 and 1, I'm going to be horizontally stretching it. So again, if this is my parent function, horizontally stretching means you're pulling. So horizontally I'm pulling that out, which is causing my graph to get wider. So horizontally stretching is going to have a similar effect as vertically compressing. So again, it's tricky, but you've got to pay attention to where that multiplier is, if it's on the outside of the function or if it's in the inside of the function. When it's on the outside, you're multiplying the output value. So you're going to evaluate it, and then once you have your answer, you multiply it. If it's inside the function, you are going to be multiplying the input. Which again is going to cause things to be just a little bit more difficult. Our main emphasis is going to be on the vertical stretching and compressing, but you will see some horizontal as well. All right, so let's say that that multiplier, whether it was greater than 1 or a fraction between 0 and 1, if that number being multiplied on the outside was a negative, that is going to cause our function to reflect over the x-axis. And again, I'm just using the parabola as our example. This is the x-axis, this is the y-axis. So if I have my parabola, my parent function, and I'm going to reflect it over the x-axis, I'm reflecting it this way, which is going to cause my parabola to open down instead of up. If that negative occurs inside of the function, then it's going to be reflected over the y-axis. So here's my parent function, here's my y-axis. This one is not going to really make a difference in this case. If I'm reflecting it over the y-axis, you don't really see a difference because a parabola is going to be symmetrical. So it's going to fold on top of itself in this particular case. That's not always going to be true if there's a transformation and it's been moved. But in this case, it's on the y-axis. So let's use a linear equation. So this is a parent function, y equals x, our linear parent function. If I were to make that with the reflect over the y-axis, this would now be my line. If I flip it there. So on the outside is going to be a reflection over the x-axis. Inside the function is going to be a reflection over the y-axis. All right, we're getting to the end of our rules. F of x minus c. So if I am making a transformation inside, not a multiplication, but an addition or subtraction, that's going to cause a horizontal shift in our function. And that's going to be a shift to the right. Notice that if I'm subtracting c, so let's say that this was f of x minus 5, my c value is actually a positive 5 because I'm subtracting what c is. Therefore, because my c value is a positive, I'm going to move to the right. This is really representing x minus a negative. Let's call it a 5 again. So if it was x plus 5, it's really minus a negative, giving me a c value of a negative 5, and that's why it would be a horizontal shift left. Anytime addition or subtraction is happening inside of your grouping symbol, it's going to go the opposite direction. When the addition or subtraction is happening outside of the function, that's going to be a vertical shift, and it's going to go in the exact direction that you see. So a positive d is going to move you up. A negative d is going to move you down vertically. So that's a lot of rules for you. Just make sure you keep this sheet and have it available for a reference as you are doing your problems. Now let's talk about 3 of our parent functions without transformations. A constant parent function is f of x is equal to 1. Maybe you're not used to seeing f of x. You're generally used to seeing y equals 1. Y equals is going to be a horizontal line at 1. You can also transform vertical lines, x equals, but for now we're just going to deal with that horizontal line at 1. A linear function is f of x is equal to x, which you're used to seeing as y equals x. Y equals x has a y-intercept of 0, a slope at 1, and you go up 1, right 1, or down 1, left 1. And that would be our linear parent function. Your quadratic is f of x equals x squared, Again, you're used to seeing it as y equals x squared. That has a vertex at 0. It's symmetrical. If you plug in 1, 1 squared is 1. If you plug in a negative 1 squared is also a positive 1. If you plug in 2, 2 squared gives you 4. If you plug in a negative 2 times negative 2 is also going to give you 4. If you plug in 3, you get 9 and negative 9. Again, your parabola, your quadratic, is symmetrical. Whatever you have on one side, you're going to have on the other. These are your 3 basic parent functions without any transformations. So let's go ahead and look at some of those transformations now. So our first example is we've got y equals 3x. What kind of function is this? Because x is being raised to the first power, this is a linear function. What transformations exist here from the parent function? So we have f of 3x. And I actually think linear is almost trickier than a quadratic, because when you multiply that 3, you have your a value on the outside, which is going to be a vertical transformation, and because it's greater than 1, that means that you're going to have a vertical stretch by a factor of 3. Now, that's really not going to be any different as if I would have said this. So in a linear function, the a and the b, the vertical stretch and the horizontal stretch, is really going to both happen at the same time, and they're going to happen in this, together. So take the function y equals 3x, which we just discussed, and shift that function horizontally left 3. So if I'm going to go left, I know that according to my rules on the front page is I'm taking my function, and left means I'm going to be adding 3 because it's the opposite of what I think. So I want to come up with this new equation. This is just representing whatever kind of function you have, whether it was an x squared or a 3x cubed. So we're going to replace the function that we started with, and the function that we started with was 3x. So I'm going to take 3, and this is our x plus 3. Now when you look at your equation from this form, you can see that you have a horizontal shift left 3. You took that original equation of 3x, which was not our parent function is y equals x, but we took that function that we were given and we shifted it left 3. Note that this is the same equation as if I were to distribute that. So y equals 3x plus 9. If you were to graph these two equations, you're going to get the exact same thing. So when it's in parentheses, you're able to see what kind of shift happened. When you multiply it out, it's easier to graph. You've got your y-intercept and you've got your slope. Again, I think that linears are the trickier ones to deal with. All right, our second example. Given the linear parent function y equals x, write the equation that shows a horizontal shift right 2. So I think about the fact that I know that it's a horizontal shift, so that's going to happen inside of the parentheses. So I've got y equals inside x. I'm going to go right 2. When it's inside of the parentheses, I go the opposite of what I think. Right, I would normally think plus 2, but because it's inside, I've got to go x minus 2. You can choose to leave it like this, but know that that's the same thing as just x minus 2 because there's nothing being multiplied on the outside of the parentheses to make any changes. Does the equation y equals x minus 2 represent a horizontal shift right or a vertical shift down? Investigate and explain. So we're going to start with our parent function, and our parent function for linear is just y equals x. Let's go ahead and graph that so we know starting point at 0, and we have a slope of 1 going in both directions. Again, this isn't our graph, this is our parent function. I want to see our equation, y equals x minus 2, is that representing a horizontal shift right? So did I take my graph and shift it right? Or did I do a vertical shift down? What I want you to do now is go ahead and investigate. Take that graph and shift it right. Take that graph and shift it down and see which one of them is going to give you that equation, y equals x minus 2. So pause your video and go ahead and try that out. All right, let's see if you found the same thing I found. When I moved that line to the right 2, I saw the slope of 1 going up and over. If I moved it down 2 with the slope of 1 up and over, I found that it was the same line. I have a slope of 1, a y-intercept of -2. So that equation actually represents a horizontal shift right, and it represents a vertical shift down. The reason for that, again, because I said linear equations are trickier, is if I were to put the x minus 2 inside of the parentheses, which shows the horizontal shift, there is no slope on the outside multiplier changing those values. So that's the same thing as just y equals x minus 2. If I were to have the function and then show the shift on the outside of the function, which represents the vertical shifting down 2, again, I have the exact same equation. This is going to be true because your slope in this case is 1. So be aware of sometimes these tricky equations do have multiple transformations that maybe you don't see right away. All right, example 3. Is y equals x squared a parent function? Explain why or why not. So go ahead and press pause and think about it, come up with an answer, and then when you are done, go ahead and press play and see if we got the right answer, the same answer. All right, no, this is not a parent function. No, the parent function would be y equals x squared. This particular graph of y equals a negative x squared has been reflected over the x-axis. So make sure that when you see a question like this on a quiz or a test, you have a complete explanation. You can't just say no. You have to say why. The parent function would be x squared and explain why this is different than the parent function. This is representing a reflection over the x-axis. That's why it's not the actual parent function. All right, 2 more and then we're done. Describe the transformations made from the parent function. So we go ahead and we look. You're actually going to follow, if you were to graph this, you would follow it in the order of operations. So we would do what's inside of our parentheses first, and when I look inside of the parentheses, I see that 3. Because the 3 is inside of the function, that is representing a horizontal stretch or shrink. And because the value is bigger than 1, when it's in those parentheses, remember, it's always opposite of what you think. Even though it's that whole number, because it's inside, it's going to actually be a horizontal shrink by 1/3. The number is exactly what you think when you see it on the outside, but when it's on the inside, it's the opposite. Then attached to that, we see the negative on the outside. That is representing a reflection over the x-axis. And then last, we are subtracting 2. Because the subtracting 2 is not inside of the parentheses, that's showing our vertical shift. And the vertical shift in this case is negative, which means it's going to be going down 2. All right, last one. Write the equation that results from the following transformations. So we are starting with y equals 3x squared. This function is going to be vertically compressed. That means that your a value is on the outside of the function, and the compression means it's going to be between 0 and 1. It's going to be that fraction. And in this case, it's going to be 1/3. After you do that, you're going to follow that with a shift right 4 and then down 1. So we're going to do these in steps. Our first step there is to vertically compress it. So we take our function. The vertical compression, again, is on the outside by 1/3. And this is the function that we are compressing. So that's going to leave us with y equals, we distribute that in. 1/3 times 3 is going to leave us with y equals x squared. After we've compressed it, now we're going to shift it to the right 4. When I shift it to the right, that's a horizontal shift, which means it's going to happen on the inside. So currently I'm at y equals x squared. When I shift that, it's going to give me right inside means the opposite, so x minus 4 squared. And then my last transformation is down 2. A vertical shift is going to happen on the on the outside, and down means -1. So if I take that function of y equals 3x squared and I perform those 3 transformations, you have to be careful about the order. That's going to be my final equation. All right, and that is it for today.